Yeah, so I'd like to, I'll just jump right in. And so what I'd like to work through today is the data, some of the data issues surrounding AI. So this will get a little more technical, I guess you would say, although I'll get up into management land as well, um, you know, for part of the talk. So who am I? Um, you probably know me from some of my work in the Agile community. I'm going to leverage a fair bit of my background in data today, of course. I was the thought leader behind the Agile data method, many, many years ago. And I'll talk about some of the fundamental data quality techniques captured there as well. I was also the co-creator of PMI's Discipline Agile Toolkit. And as you heard, if you're here for the panel, I recently finished off a master's degree in AI. It was a 2-year effort. I'm just about to convocate in July, actually, so I'm um, not quite there yet. But the work is done. I'm just waiting for the ceremony stuff. But fair enough. So what do I want to work through? I'm going to start with a brief definition of AI, very high-level definition of AI, just to sort of put into context what I want to focus on, which is machine learning, a subset of the overall AI space. And then I'll get into data quality and how it relates to AI. And I'll finish with a little bit of a discussion about selecting the right data quality techniques. Now, that's actually a phenomenally big topic. But I'll do a brief overview of it, just to give you a flavor of some of the things you should be thinking about. I think the one of the ideas I want to get across is the need to actually deal with data quality. Our organizations suffer from a lot of data debt. And this is harming us for many reasons. A huge challenge with AI is the law of GIGO, garbage in, garbage out. So if we have if we're training our AIs on low quality data, if we're operating our AIs and putting low quality data into them and asking them to make a prediction or to do something, we're going to get a poor quality answer. And I think this is what a lot of organizations are running into. And I'll actually share some industry stats on this very thing. So my three main messages today are data quality is certainly a critical factor for successful AI. Not the only factor, but it's the factor I'm going to focus on today. Um, the best place to address data quality issues is at the source. I don't have exact stats on this, but I think about 90% of organizations are failing miserably at this. It's hurting them. And like I said, we'll see some industry stats. I think the data community doesn't quite have a handle on this, and we can see that from their behaviors, and I'll talk about that in a bit. Um, and the data quality challenges that you face will drive your choice of multiple DQ techniques. So one size does not fit all. We've talked about we mentioned ways of working throughout the other presentations in the panel. And the reality is you've got to know what way of working, what technique, what strategy, what practice, whatever you want to call it, you need to choose and you need to apply to solve whatever challenge you face. So one size does not fit all. I don't believe in the concept of best practices. I'll share some hardcore examples of this in a bit, including some of my own work. So I'll take a shot at myself. And the reality is that every strategy has advantages and disadvantages. It will solve certain problems, but will also put you in a new situation with new problems. It'll only like think of a hammer. A hammer is very good at certain things, like hammering nails and maybe breaking glass and a few other things. But it's you need more tools in your toolkit other than just hammers. So you use your hammer, use your screwdriver, use your saw for what it's good at. Understand how to use these techniques. Understand how to apply them in the right situation. And unfortunately, a lot of the methodologies do you a disservice by not putting the techniques into context. So we'll talk about that a bit. I'll talk about what I look for in the context in techniques, and I'll point you to an URL or a link that goes into probably way too much detail than what you would care for. But anyways, if you're into detail, it's there for you. So what is artificial intelligence? And like I said, this is more of a layman's definition other than a PhD person's definitions. But so AI, to me, are just computer systems that are able to perform tasks that would normally require human intelligence. So we're interacting with these AI systems as if they're people, and we've heard examples of this, right? Like we didn't come out and say it exactly. Well, actually, Jurgen was pretty close to it, saying that he's got several AIs set up that he uses for different, he interacts with them for different things and different aspects of his writing, and this is good. Like he's using AIs for to get advice, basically. And earlier I was ranting about how I don't use AIs to write, but I do use them for advice. So it's similar to what, and I wasn't clear about that at all. Um, but I will brainstorm using an AI system. I will ask it for how would what do you think of this? Like some of the examples he was giving. But I certainly don't use it for writing text for me. Just like I wouldn't outsource writing to a human, ghost write this book for me. I wouldn't do that. So I'm not going to ask an AI to ghost write a book or a chapter or even a few paragraphs for me for IP that I care about. Now, if it's marketing stuff, yeah, okay, maybe, probably actually. I don't really write marketing stuff, but if I needed marketing stuff, I would probably use an AI for that and tweak it a bit, keep the human in the loop. But yeah, I wouldn't put a lot of effort into trying to write my own marketing stuff. It's not my skill, and frankly, an AI can write that pap. I use the word pap on purpose. Now, a subset of AI is machine learning, and this is what I'm going to focus on today. So these are computer systems, AIs, that are trained without being coded. So it's not, whereas expert systems from the past, you wrote rules and you wrote or you trained you had humans training the expert system. Machine learning, the software learns on its own. The models create themselves, and there's a little more to it than that, but that's basically what happens. Then we have a subset of machine learning, which is called deep learning, and this is where most of the work in machine learning has been done over the last 15, 20 years. And this uses a technology or a technique called artificial neural networks, ANNs. And what you're probably familiar with, and it certainly has fed the hype cycle over the last couple of years, are large language models. And this is a subset, again, of deep learning of this generative AI stuff. And so, which is great. It like any system, like any tool, it has its advantages and disadvantages. Understand how to work with it. But my concern with LLMs is with the fact that they've taken over so much of the airspace in the AI community. Like that's all everybody talks about. And fair enough, right? It's new and it's hype and the tech bros are making money at it. But it's not the only game in town. So this is an important message that I want to get across is that um, don't let the LLM hype make you miss the wealth of other techniques and other models in the AI space that you could leverage to take on your problems and to address whatever challenges you're trying to address. And I suspect one of the reasons why we're seeing such a huge failure rate with corporate AI is because a lot of organizations don't have the people with the skills to do the job reasonably well. And that's the generalization. But they're trying to apply LLMs for the wrong problem space. So, for example, it'd be the equivalent of if I had a crack in a window, I'm not going to be able to fix that window with a hammer. Now, I might use a hammer to smash the glass out, fair enough, but there's a lot of work in fixing and replacing a window that is not hammer related. So I think what's happening is organizations have these LLM hammers right now because they're really cool and who doesn't like them? But it's not the only tool in your toolkit. So anyways, just be careful, be smart about it. So anyways, um, to understand the data quality issue, we first need to start with understanding the machine learning lifecycle. Now, when you read the literature, it's pretty sparse on life cycle on overall on overall life cycle stuff. So most of the literature talks about, well, we train AIs and then we throw them out into production and we operate the AIs to make inferences, and there's a feedback cycle. So at a very high, this is a high level view of what a lot of the literature talks about, and there's great and gory details about how to train, but it's interesting to see the advice starts at this very high level view and then instantly dives down into far more detail than you want. But that's okay. So I'm going to try to fill in the middle ground here, and I'm going to first start with a project-oriented life cycle. Which is not a good idea, but I'm going to start there because it's a good conversation to have, and then I'm going to move away from this. So, just bear with me for about 5 minutes. So if we start digging down into this life cycle, from the previous slide, then some of the major activities, that you'll hear about and you'll actually do are this, right? We got to figure out what type of model we need to work with. We've got a lot of data prep. One of the myths in the data science community, or one of the complaints, I guess, is, data or jokes. Data scientists spend 80% of their time cleansing data and the other 20% of their time complaining about cleansing data. And yeah, it's definitely a joke, but it's not far off, and that's a bit of an issue, which we'll talk about in a bit. So then we train the models, we do some testing, we validate the models, and eventually we deploy. And we might be deploying on a regular basis, doing ML ops, and which is what I'm going to work up to. But we deploy on a regular basis. So if we take it to the next level, when we start looking at, well, how does construction really work? It's not this linear process, right? So, and when you're writing books about this, of course, chapter one talks about this, and chapter two talks about that. So your books force you into a linear discussion, but it looks a little bit closer to this. So we choose a training strategy. I think the an SGD model will be the way to go. Then we do some very iterative and incremental work. We validate in parallel as well. So we're constantly testing our models. We might be coding and training all day, and then we run a test job at night type of a thing, or maybe it's running in parallel. However your infrastructure is set up. And then every so often we deploy. Now, right now I'm showing deployment as a phase, and certainly the first time you deploy it pretty much as a phase, because you really haven't got your act together, you haven't automated everything. But deployment tends to be underestimated. And what I mean by this is there's some very important decisions you got to make. So are we running this AI in the cloud? Where are we running it? It's basically the issue. Are we running it in the cloud? Are we running it on edge devices? Are we running in a combination of the two? Is it on-prem? Is it on a SaaS? Is it international? How many AIs are we building? So, for example, I worked with an insurance company a while back, and we were doing building an insurance fraud detection thing. And the reality was that we built multiple models because in automobile insurance fraud in Toronto, where I live, is different than auto insurance fraud in whatever city or wherever you live, right? There's different rules, there's different cultures, there's different ways that fraud can be committed, or the culture of Torontonians leads them to committing fraud in different ways than people who live in your city commit fraud, for example. And this is just true, right? It's just international cultures are different when it comes to fraud. It is what it is. So one model does not fit all, right? So you end up deploying multiple models to address fraud, throughout your marketplace. So anyways, weird example, but it is what it is. Now, and this is also obviously not a project. I'll start hammering on the project issue, that we see feedback coming back from production, right? So we're in multiple release land. If your AI development is successful, you build it, you release it, you learn, you build, you tweak it, you release it. So it's this very iterative thing. So ML ops is really the way to go. But it's also not really as agile, or at least not pure agile as we would like to think either, because we really want to do some upfront envisioning. So one of the challenges with AI, and it currently runs like an 70, 80% failure rate, depending on whose stats you listen to. But it's high. Like, it's, who cares what the actual number is? When it's that high, there's a problem. And part of the problem is people are trying to apply AI when they really shouldn't be, right? Or when they don't have the skills or they don't have the data. So you want to do some upfront thinking about this. Like, what's your overall business process? How are you going to use AI to augment your workers, right? So, and where in the business process do we want to apply things? Or are we creating a new business process? Well, what's the vision for that, right? So we got to do a little bit of upfront thinking. We don't want to go nuts about it, but we really do want to think about a few things. Like on the data side of things, we need to do some initial data exploration, like fundamental questions along the lines of, well, do we have the data? Is the data of sufficient quality? Can we address whatever challenge, realistically, can we address whatever quality challenges we've got if it's not the case? You need to be asking those questions up front, because they're more than likely you're going to get burned from the data, because of data related issues, or other issues as well, right? So you want to do a little bit of upfront. You want to be exploring your viability all the way through. So that bubble should probably be going across. Even when you're in production, I still want to be doing a reality check. Is this viable? Do we actually implement something people want to do? Because just because you release something doesn't mean that you've been successful. So, anyways, this is more of a, ignoring the feedback cycle loop. This is more of a project-based view at a high level of the machine learning lifecycle. Now, if you're into DevOps, or in this case machine learning ops, then this is probably a better rendering. And I'm just going to map the bubbles in the previous slide. I'll map it to this sort of a life cycle. I prefer some sort of a iterative incremental life cycle like this, and this is popular because it's really cool because a Mobius loop. But it's got that cool Mobius loop thing going on for it. But anyways, this is a much more realistic life cycle. Although there's also the crisp DM life cycle from the late 90s, early 2000s. If you're a data scientist, you're probably familiar with this. I would rather render it like this, realizing you got to start with envisioning somehow, and you're going to do a lot of iterations around the technical work, and then you're going to deploy every so often. So in Microsoft, if you're a Microsoft fan, they've got a very nice rendering of this, showing how people, where people are involved in the life cycle. But be that as it may, so but some people like crisp DM, some people don't. Like I said, I prefer the MLOps version of this life cycle, but they're all the same. They're different rendering, different visual renderings of the same basic ideas. So I would choose either this or the previous slide when it gets down to it. So, anyways, data. So, actually, before I leave this, I do want to put this in an agile point of view. So this is far more agile in a view, and as is the MLOps offering. But really, but when you start your initiative, it's absolutely critical to understand you are going to invest some time. I hope you are going to invest some time doing some upfront envisioning, some upfront exploration of the problem, some upfront exploration of the of your technical environment, like quality of data and things like that. You're going to put the team together. I'm not really going to get into this in this talk, but an absolutely critical issue when you're putting an AI team together is to put together a team that's very, very diverse, because of the bias. And I'll talk about bias in data in a bit, but because of if you want to detect bias in your data, and there is bias in your data, there is always bias in your data. The more diverse your team is, the greater the chance you're going to understand what that bias is, and hopefully address whatever that bias is. But anyways, I'll talk about that, and I'll share a really good book as well, book reference for understanding bias. And there's several, but I'll share my favorite. Data debt. So what is data debt? So data debt is a form of technical debt, poor quality. So just like I would hope you'd have to be spectacularly thirsty to dip a cup into this river and pull, drink from this river. Even with those life straw things, if you know what those are, I certainly, I'd have to be phenomenally thirsty to drink from this. And this is a reasonable rendering of a lot of your source data in some organizations. So, a metaphor. I like to use I've adopted Rob Siner's. Rob Siner is the author of several very good data governance books, like a lean governance approach, non-invasive data governance, his series of books. And he uses a metaphor of data being the new water. Some people like to say data is the new gold because we're making money from data. But so what? I can't, gold will not keep me alive. I need like water is absolutely critical to our existence. You can only go 3 days, 3 or 4 days, I believe, without drinking liquids before you die. So water is reasonably important. So a lot of us like to use the term, like to use the metaphor of data being the new water. So here's the metaphor. I go to my tap. I want a glass of water. Pour some water into the tap, and this is what I get. I'm not happy. That is not something I want to drink. So what do we do? Well, how can I fix this? So I've got a problem, right? So I got dirty water is coming out of my tap in my house. What do I do? So I could filter it. I could use a Brita water filter, for example. So take the dirty water, pour it into one of the Brita jug, wait a couple minutes, and I get clean water. That's great, but if water is coming out of my kitchen tap, dirty water is coming out of my kitchen tap, it's probably coming out of my bathroom taps, out of my shower. So this filthy water is a problem for me. So the Brita water filter solves my immediate drinking problem, or that's not the way to say it, but it solves my immediate problem to drink clean water, but it certainly does not solve the real problem. So my next potential solution would be, well, I could filter it when it's coming into my home, right? I could buy a big water filter, and a lot of people will do this. So the dirty water is coming from some outside source, so we filter it through a big filter system thing, and then all my taps have clean water. So much easier. I've still got maintenance issues and stuff like that, but much easier, much easier, much better solution for my house. But the problem now is my neighbors still are getting, everybody else in my town is getting filthy water. So the problem's not really solved. So we could go upriver. So, why do we have dirty water? Well, let's look into it. And we discover that, if we go upriver, then there's a factory that's spewing garbage, it's spewing filth into the river. So that's the real problem. Like if we could only filter it at that source, now every person in the town doesn't need to have a filter in their house, right? So we could solve the problem there. But that's not the real issue. It's like, why is this factory producing filth? Because there's filth in the factory somewhere, right? So, we should filter it where the filth is currently being created, where it's currently being generated, and we should clean it up, right? So there's in the case of IT, this would be systems that are creating bad data. Well, let's clean that up. So the metaphor is one of what we want to do is we want to keep going back until do a root cause analysis and find where the real problem is and fix the real problem. Everything else is a band-aid. So in the data world, this would be the equivalent of, number one, where we filter the water with a Brita jug. That's the equivalent of doing data cleansing. And this is what all the data scientists are complaining about. They're spending all their time writing code and using tools to cleanse the data at the point of usage, right? And the theory is that, well, they've got to do that because the data sources are filthy and they don't have access to fix the data sources. Woe is them. This is the best thing we can do. Um, Number two, the metaphor would be, well, wait a minute. If we fix the data, if we use a data warehouse or something like data lake house, whatever, a bunch of different terms for the same basic ideas. If we get our data from a data warehouse where it's been cleansed in the data warehouse. Well, how does that happen? Well, they get data from multiple sources. They cleanse it when they bring it into the warehouse. So now they've got clean data in the warehouse. Now I can just, so this is the equivalent of having a filter as it's coming into my house now, right? So, anyways, so if it's cleaned at the data warehouse level, then that makes life easier for anybody using the data. Um, or if we filter it before it's dumped in the water, the equivalent of that is say something like data contracts, where we put some sort of an API in front of the data source that fulfills a data contract, and so the source is wrapped by something that a filter is basically put on the source, so that way only if we use the API, then only clean data comes out of that database. If we filter it at the source, that just means that's basic, 3 and 4 is basically the data contract, I think. But then we still need to fix the actual source. Like, so, because the real problem now is, well, whatever is using the source database or source data file, whatever the source happens to be, all the code that touches that crap data, um, there's extra technical debt there. It's all counteracting whatever the problem is. So if we fix the database, fix the actual problem, and we fix the applications or fix the business processes, as the case may be, that are creating the bad data, then we've solved the real problem. Because every other solution that I talked about, other than fixing the actual problem, is overhead. It's technical debt, it's costly, it's inconsistent. The closer we get to fixing the actual problem at the actual source, it becomes less expensive. It becomes less expensive to do. It becomes less expensive to operate, and it becomes more consistent and less likely to break as long as we keep an eye on things. So my advice is to do the right thing. The challenges, of course, is all organizational culture, right? We don't have the time to fix our problems. We don't, the team that owns the database doesn't have the funding, basically, to clean up their mess. They probably desperately want to clean up the mess. They're just not being allowed to, because it's not cool, right? It's, cleaning up for example, cleaning my kitchen. I'm sure it's messy right now. It's not a lot of fun. I would much rather be at my desk, writing or interacting with people, not cleaning the kitchen. But cleaning the kitchen needs to be done at some point. So, and this is the actual challenge. We need to find the time to clean things up. So let's treat data like a corporate asset. Because it is like, it's really easy to say that data is a corporate asset. Everybody shoots their mouth off about this all the time. But if I walk in your organization and senior management is shooting their mouths off about data being a corporate asset, and then I look at the data and I see, I look at your data sources and I see this very clearly, this river tells me that water is not something that's important in this town. Keeping the townspeople healthy with clean water is not important. Assuming people are pulling drinking water out of this river, right? It's certainly not important. So data debt is the data version of technical debt. So if you're familiar with technical debt, it's often talked about in terms of architecture and poor quality code, poor quality design, and it certainly is. But because the concept of technical debt originally was coming from the programmers for the most part, they didn't give a lot of focus to data quality debt, or data technical debt, I should say, or data debt, which shorten it up a bit. But and this is a problem. So we really need to do better. And frankly, the Agile community needs to do better on data as well. Agilists, for the most part, have over the years focused on like Agile programmers, I guess, have focused for the most part on coding and writing better quality code and all this stuff. And they've really sort of not focused on data. They're not data experts. Their idea, well, I have to worry about data because we, access it through some sort of data access layer or through an API or web service or something. That's just, that's just unacceptable. It's, and this is one of the reasons why the data quality debt's built up over the years, is because we really haven't focused on it. Focus on it, you're not gonna, nothing's gonna happen, right? So what are some of the causes? And this is a prioritized list. I don't have data. This is all anecdotal evidence, so take it for what it is. Certainly, all these are issues. You might want to pop one or two, reorder it slightly differently. But I think the biggest cause of data debt and technical debt in general is our business stakeholders prioritizing time to market. We've got a date to hit. We've got a budget to hit. And as soon as you're in this on time, on budget mindset, um, quality gets short shifted. It just is what it is. And certainly data quality does, particularly when the technical people that are being forced to take shortcuts, and if they don't understand data quality, if they don't have data literacy, they can make some just one or two bad decisions, almost always driven by on time to on budget thinking, can result in very bad quality data over time. Like just having multiple data sources, for example, just we're going to create yet another database because it's easier to do than it is to use the existing database. That's a data quality problem. Do the developers know? Do the developers even care? Probably not. They got to hit a date, right? Poor quality data management or ineffective data management. The traditional approaches to data management haven't worked out so well. Luckily, a lot of data management stuff is being automated by AI, so things are getting better quickly in that space. Having multiple data sources or multiple silos, the applications are silos, the databases that they use are silos, and they all work fine by themselves. But then when you start combining data from multiple sources, it's a mess. Like it could be high quality data from the point of view of the single silo, but together it's a dog's breakfast, right? And so, data warehousing people have been dealing with this for years. AI people, like data scientists particularly, have also been dealing with this for years, just because of different semantics. And there's a bunch of good, or a bunch of reasons. Good might not be the right word, but there's a bunch of reasons for why this is happening. And then just bad coding, just almost always, once again, because of on time on budget, we got a short shift what we're building. So many reasons for why this data debt occurs. Some of them are people and process related. Some of them most of them are people and process related. Some of them are tech related, I guess you would say. So what's the impact of data debt on AI? So what happens when we train our AIs on poor quality data? So we have this robot drinking poor quality water for some strange reason. Um, so, like I said, okay, so here's some industry stats. So from this survey around about a year ago now, by the K2 folks, they found that data quality problems were the second most challenge for enterprise applications and for enterprise AI. So half of companies were running around on AI, on their AI pilots and AI projects because of data quality problems. Um, this is from Scale AI. So the Zeitgeist, I probably didn't pronounce that right, writing this report. I love the Scale AI's guys. They do phenomenal consulting organizations do phenomenal jobs. Their conferences are amazing. Their publications are amazing. They found that some of the top challenges of companies successfully doing AI, roughly half again, were had concerns about data and privacy. And for the organizations that aren't adopting AI, the number one reason was security and data concerns. So, not sure how much of that is data quality issues, but certainly um, more. I bet you it's mostly data quality because security is fairly straightforward to nail if you choose to. But it depends on the organization, I guess. So going back to look at the life cycle. So and one of the good things about the project life cycle actually is that you can map. It's easy to map certain classes of concerns to the life cycle. So, anyways, so where am I interest? Where can data quality problems bite me? Is the question. Well, obviously, when I'm initially exploring data. At the beginning of an initiative, yeah, I could run into quality problems there. And frankly, one of the big questions that I want to ask while I'm doing this initiation, this envisioning stuff, is do we have the data we need? Is the quality good enough? Now, you're going to be making guesses early on, but my experience, having done this several times, is that your existing data people have a pretty darn good understanding of the quality of the data and the challenges you're going to run into. What I've also found is even though it's almost always a negative discussion, it's overly optimistic. So what'll happen is at the beginning, during envisioning, you'll realize, yeah, we got some data quality problems, but we'll be okay. Will be the level of decision that we make, and then we get into we get into actually building and working things, and we start diving down into actually working with the data, and we realize the problem is bigger. It's a bigger mess than we thought, right? And this is just natural. You're almost always overly optimistic at the beginning of something, and then, reality hits when you start doing the real work. And almost always reality hits, and the data mess is even bigger than you thought. And certainly, when you were training the model, um, once again, garbage in, garbage out. So we got to work with the data. We got to make sure we've got the right, and we could have perfectly clean data, or darn close to perfectly clean data, and then we end up training and the models we train are still not good enough. We just don't have the level, whatever level of, prediction accuracy rate we want. We just can't get. It just isn't there. I mean, and yeah, you can make synthetic data, and there's ways around that, but there's limits to everything, right? And you just might not. You might hit a limit that just doesn't get you to what you actually require of your AI. So stuff happens, right? And this is, I think, one of the reasons why we're seeing some teams fail is that, yeah, so they did a great job, it just didn't work out for them. And of course, when we're validating, right? So we've got test data that we need to validate our models against. You basically carve off a percentage of your data to test. Of course, if you're having data quality problems elsewhere, you're also going to have it in your testing efforts. When we're making inferences, when we're actually up and running in production, we could have a fantastically good model, but then we've got bias in our data. So the book I promised to tell you about, there's a really good book called Weapons of Math Destruction, Math, not Mass, by Kathy O'Neill. And so, frankly, any book that Kathy O'Neill has written is great. But this is a particularly great book because it's basically a book of horror stories about data and AI, almost always because of bias. And the stories are very similar. Like, they very well-intentioned people doing the best they can. They've got a great vision for how they want to use this data or use this AI to improve the universe. They've always got, there's always well-intentioned stuff by good, competent people, and then bad things happen once it's in production, once it's being actually used in practice. People are being denied loans, which, if you get denied a mortgage, and you're a young family, that can be devastating. Has a huge impact on the overall quality of your life, or potentially does. Legal expert systems for advising judges. People were potentially going to jail, or sentences were being lengthened because of the advice coming out of some of these AIs. And they weren't built to do that. Like, nobody thought, yeah, we could throw more people in jail if we use AI. That wasn't the intention, right? Better fairness, increased fairness and increased justice was actually what they wanted, but they didn't get that because of the bias in their environment, because of the unknown bias in their data, which reflected their business processes from yesteryear, which reflected the bias of the people running those business processes. And then finally, of course, this new data we're getting in from reality, and the new learnings we're getting. There's this concept called model drift, and the models aren't drifting; it's reality is drifting. But we blame the models. And the idea here is you build something, you deploy it, and that's something. Let's assume you did a perfect job with perfect data and all that sort of stuff. I deploy a model right now, and we start running it. Well, the world is moving on, constant rate of change, all that good sort of stuff, or increasing rate of change. So several days later, my model no longer reflects the reality of the environment that it's in because it was trained on data from up until today, but several days from now, it's a slightly different world. So, and the longer and longer we go without redeploying, based on learnings, the more and more the model is out of sync with reality. It just is what it is. So this is why you want to redeploy on a regular basis. So, some of the potential data quality issues faced by machine learning teams. This list is certainly not complete. It certainly isn't specific to just machine learning. Like inconsistent data values, for example. Anybody using data has this as an issue. But all the privacy and security issues, data bias. There's always bias in your data. Do you understand that? And the issue with biased data is to do what you can to reduce the bias, to get it to a point that it's good and you can live with it. You can live with the bias. Harsh to say that, but that's the reality. You just might not have enough data, the semantic differences between multiple sources, and so on. Something that is for the most part. Specific to AI is data poisoning. So, as we all know, there's a lot of organizations and groups out there that are purposely creating misinformation manipulate elections, to manipulate people in general. Here in Canada, we have an election coming up on the 28th. We are being inundated by right-wing misinformation, a little bit of left-wing misinformation, but for the most part, the right-wingers are really just spewing garbage out into the media space right now, and it's going on the web. People are training their AIs right now on this purposely generated misinformation. Then we have this, people using AIs to write blogs, to produce videos, to produce pictures. Oh, this one isn't produced by AI, but most of my pictures in this deck are produced using AI. So if I was to put those out, well, I have put this up there on the web because it's on SlideShare, but if people are training their AIs on these AI generated images of mine or that I created using AI, that's a form of data poisoning. If I was writing text, if I was publishing material on my sites generated by AI, that would be a form of data poisoning because what happens is I publish something and then sometime later somebody scrapes my site for information to train their AI on. Well, they're now training their AI on AI generated information. So the quality is going down. This is one of the reasons why I am adamant about being very careful about how I use AI when I generate IP. Because this is an issue that's going to bite us on the ass. Well, it is biting us on the ass, and excuse my language, but we have to be very smart about this. So just before I wrap up and go questions, so what do I look for in techniques? How do I judge which technique to use? So the issue is that, well, there's many different data quality techniques out there. Some of them are lean more towards the traditional end of the spectrum, and that's okay. Some lean more towards the agile and lean end of the spectrum, and that's okay too. Use the right technique for the situation you find yourself in. So there's other techniques and other techniques and so on. So at my site, at the Agile Data site, and I've got an URL coming up for you. Um, I probably rated 25 or 30 techniques. There's many, many, many more than what I've rated, but I've rated some of the more popular ones or more common ones, I guess you would say. And they all have advantages and disadvantages. There's no such thing as best practice other than from a marketing BS point of view. All techniques, all practices are contextual in nature. They're a good idea in some situations and phenomenally bad ideas in others. And you, as a practitioner, you need to understand when to use when to use the technique and when not to. Use the right tools for the job. So, how do I put these data quality techniques into context? So, I've identified 5 comparison factors that I look for when judging data quality techniques. There might be a sixth, but I'm not happy talking about that right now, but I suspect there's one more, but I don't have enough evidence of that. So anyways, leaving it alone for now. For the first one is timeliness. So at one end of the spectrum. So as I go through these five techniques, the left-hand side is where I don't want to be generally, and the right-hand side is where I do want to be usually. So anyway, so timeliness. Am I reacting to a problem? Or am I being proactive in avoiding a data quality problem? Because a data quality problem that never existed is almost always less expensive to deal with than a problem that's been there for years. Right, that's the logic. Um, how well can I automate this? All the way from, this is a purely manual technique to, yeah, I can automate the living heck out of this and just put it in my MLOps infrastructure, code, quality by code type of a thing, or process by code. The What's the effect on the actual source? So, for example, data cleansing. So all this work that data scientists do to prep the data to train their AIs or to do what other things that they're trying to do. That's not having any effect on the actual source data because they're getting their data from multiple sources, combining it somehow, then they're prepping it, then they're using it for whatever it is that they're using it. So that's like the water the water filter the Brita water thing, right? It's yeah, I got to do it because I don't want to die of poisoning, but it's my least effective option to deal with that quality problem. Or am I actually fixing the problem at the source so that way we fix it once, we get it to the point where it's no longer being polluted, and that way nobody downstream ever again has to worry about polluted water. We can save the townspeople. That's really what we should be doing here. When do I realize the benefits? And so this is interesting. I look at this because there's many data quality techniques which are perfectly fine, but they have a multi-year, a very long-term payback period. Um, that's almost useless because those sorts of techniques require long-running business processes. They require like multi-year support from the business, multi-year support from your executives. They're phenomenally fragile to reorganizations because the new big boss comes in and they're going to change a few things that the old big boss did. And so if there's this multi-year payback thing, gone, right? Total waste of time and requires people to focus for multiple years and we all know that people's focus isn't the greatest these days. So the faster the payback period, the shorter the payback period, more than likely the better the technique. And finally, how many skills are required? Or what's the level of skills? Is this like a really straightforward thing that I can teach anybody, or does it require really sophisticated skills? So those are the factors that I look for. I'm going to rate a couple techniques, and then I'm going to go to questions. Oh, and like I said, if you drop by that Earl right there, I will happily overwhelm you with information about this and ratings. I think of about 25, 30 some odd techniques. So in the machine learning lifecycle that I showed earlier, and this is now bringing data sources into play, what are the types of factors? So of the five factors, what ones am I basically looking for at different points in the life cycle? So when I'm using data, so during envisioning, when I'm using internal data, I'm looking for techniques that are reactive and immediate benefit and that are reactive because of the nature of what's going on. And well, you can read all this and so on. So the point that I'm making is that with different contexts at different points in time of what I'm doing my priorities shift. And because my priorities are different depending on what I'm doing, depending on my context, I will make different choices for quality techniques. So whatever my context is, I want to match the best, most effective or likely the best, most effective techniques for that situation. Use the right tool for the job. So inherently I know when to use hammers, I know when to use screwdrivers, I when to use wrenches and so on. We should be able to say the same thing for these data quality technique and any technique in general. I'm just focused on data quality at the present moment. So let's rate data cleansing. So I've been ranting about these data scientists, data doing all this data prep, this data cleansing at source. Why is that problematic in my mind? Well, it's reactive. I can do a little bit of data ops automation for this. Like once you've got the scripts built to clean the data, you can automate the living heck out of that usually, or use tools, existing AI, almost always AI-based tools to do this. The effect on source is none. That's my big level of grief. The benefit realization is immediate. You do the work, you end up with clean data. That's pretty good. It's just like, I put the water through the Brita water filter. I got a clean cup of data in a minute or two, or a clean cup of water in a minute or two. And the level of skills is intermediate. There's definitely some skills to doing this. The tooling is making it better, but it's certainly not something you can just, my daughter, who has no data skills whatsoever, she couldn't do it just, off the top of her head. Probably teach her to do it, but haven't yet. Probably never will. Um, Database refactoring. So this is a technique that I pioneered about 20 years ago with Prompt Satellite. So I'm just going to say this technique is an absolute work of genius. It's the greatest thing since sliced bread. Like if I, and I'm being facetious here, right? But yeah, I'm sure you've heard this, right? Somebody writes a new book, come up with a new technique, or at least a technique they think is new, and all they can do is say good things. This is going to save the universe. It's awesome. All you need to do is this. Everything else that came before it sucked. The usual. I'm being a little extreme, but that's basically the marketing message. Well, okay, let's take a hard shot. Let's take a hard look at database refactoring, which I can safely say is a work of genius because I created it. Well, the timeliness, it's reactive, right? It's reasonably reactive. The problem's been there, probably been there for years, and I'm finally getting around to fixing it with database refactoring. So I'm fixing it, which is good, but it's a reactive technique. It would have been better not to have the problem to begin with. Not a lot of automation opportunities here. There's some great tools, but database refactoring tends to be a one-shot deal, right? You fix the problem and you move on, right? I don't have to keep running it over and over and over again. So there's not a lot of opportunity there. Although there's great tools, don't get me wrong, but it's not a DevOps, not a data ops tooling type of thing. The effect on source is direct. Yay, I'm fixing the actual problem. That's a good thing. The benefit realization is immediate. So as soon as I do that refactoring, at that point in time, from then on, the problem's fixed. Awesome. Required skills, reasonably sophisticated. Some of that is because the tooling could get better. So I'm hoping that this will move in time. But right now, you need some pretty solid skills. So anyway, so I've rated two techniques. Like I said, at that link that I shared a couple slides ago, I've rated like 25, 30 some odd techniques. None of them came out perfect. None of them came out total losers. So I didn't find any truly bad practices, could not find any truly perfect practices either. There's always trade-offs. Use them in the right situation. So to wrap up here, what were my main messages? Well, data quality is one of the critical factors in AI. We're seeing this, the experts are telling you this, the people doing the work are telling you this, the research is telling you this. So take it to heart. Um, I believe, now this is more of a philosophy thing. I can also back this up with financial numbers. The best place to address DQ issues is at the source. Fix it once, fix it where the actual problem is, and you don't burn everybody downstream, right? It's really, and that's easy enough. Build a spreadsheet really quickly. You can see that in your using your own organizational data. And really, it's a cultural issue. Are you willing to step up and fix the problem? That's the real issue, and that's sounds easy, very hard management decision. But it's a decision you got to make at some point, or you're going to just burn money and you're not really going to solve the problem. There's your trade-offs. And the problems that you face will be driven by your context. Use the right tool for the job. So I probably said that about 20 times. So anyway, so thank you very much. I'm happy to go to questions if there are any. I've seen stuff flying by in the chat, but um, John, if you
Yeah,
could.
I have a question, but let's see if anybody, we have about 5 minutes. So any questions for Scott? Either put in the chat or yeah. So maybe here's my question, Scott. In context of organizations that have a lot of quality debt, and how's competitive advantage, or I guess companies that don't have the mess will probably have advantage over companies that don't. And do you see that as a huge advantage and disruptor? If I'm a startup and I'm trying to disrupt a insurance company or a bank, maybe that's too much. That's too highly regulated. But like something that's easier to disrupt, it seems like
Yeah, definitely. So it's like anything. Like, for those of us on the in the presentation here today that are coders or were coders, we all inherently know that working with high quality code is way easier and faster and better than working with low quality code. Well, it's the same thing with data, right? It's way easier to work with high quality data. Like I said, like the data scientists complain that they spend 80% of their time on data prep. Now, it's probably really 60% or maybe 70%, depending on the situation. That is a boatload of your time and effort that you're spending cleaning up other people's data. Um, you can do, and these are highly paid, highly skilled people, and they're doing this grunt work. So, we can get them working better. But yeah, because what I want to do, I want to be, if you believe that you can leverage AI to implement better processes, to provide better products and services to your customers, to go to market with a more coherent, better offering than your competitors, then so if you believe that, and I believe that, but if you believe that, and you want to, therefore you want to build AIs, and if you also are willing to listen to the people doing this who are telling you that if your data is a mess, you're going to have a really rough time building AIs that are any good because of garbage in, garbage out, then that tells you that the organizations that have clean data, that know how to work with clean data, are going to have a much better experience than the organizations that are dealing with sewage. Like imagine living in a town where data, where you're fighting data quality, where you're fighting water quality problems all the time. I live in Toronto. I don't think about water quality problems. I go to the tap, I pour myself a glass of water, and I go. And I've never, ever, ever worried about water quality problems anywhere in Canada. It's just, and well, there are other places with water quality problems in Canada, but certainly not where I live. But imagine like living somewhere where you've got to boil water, right, in order for it to be reasonably safe.
yeah,
Imagine showering in water and it smells
yeah.
dirty. And I've visited places in the world where that's certainly true. Um,
So that's an issue because now, like I think with AI tools, you'll be able to smell, and that smell is going to be amplified. I'm assuming to some extent because AI will be able to detect that smell, right? Uh,
oh, you can't count on that. Yes, there are
at
certainly
least,
some problems
yeah,
that AI can detect, but there are the more interesting problems are the ones you can't detect. So like semantic challenges, I can't tell you.
yeah,
Like yeah, I might have a shot at detecting data semantic challenges between sources. I can certainly say, ooh, it smells like it's got a semantic problem. I can't tell you what the semantics are,
yeah,
right? Humans need to be involved. Uh,
exactly. So some things AI can assist with, but you need
yeah,
humans still to things that AI can distinguish to help with that. Yeah.
there's certainly a lot of opportunity for AI augmentation, and we're seeing that. Like I'm seeing this renaissance in the data community. It's fantastic because we're at the first point in time where data professionals can build their own tools in a coherent manner, right?
Mhm.
Like for the last 20 or 30 years, software developers have adopted open source. They've been building their own tools, and things have been getting a lot better for them. That has not been the case in the data community for the most part. But now they can actually build their own tools, and they are. And so we're seeing really good, almost always generative AI based tools for automating a lot of the grunt work and automating a lot of this. So the tools are getting better, but that it's still an augmentation play. It's not a replacement play. I don't think they're we're certainly not going to replace the entire data pipeline, whatever that happens to be. But we will certainly automate, or we will certainly augment most aspects of the pipeline is the way to look at it.
It's very interesting. Like people said, most of us are not used to thinking this way or looking at this, but and thank you for bringing attention to this because, like you said, it's going to be more and more important, and garbage in, garbage out is even more. uh,
Yeah, you're doing garbage in, garbage out at internet speed and at big data volume. Good luck.
yeah,
It's just those are multipliers. So good luck. You got to wake up. Yeah, senior man, like, and this, I'm reasonably harsh, as you can probably figure it out by now. I am phenomenally blunt with executives when I do executive training and executive education and consult. And my message is almost always wake up, suck it up, do your job for once.
yeah,
And that's certainly my message to the data community. Do your job for once. We
yeah,
would really like it. It'd be a wonderful change of pace for most data professionals to do their job. You know, if you're not fixing the source, you're not doing your job. Sorry, you just aren't. Um, you're doing
good.
what you can. You're stuck. I appreciate it. You're stuck in the situation you're in. You're not doing your job. It's not the job.